Algebra 1, section 10.7, continuing with the quadratic formula and a specific portion of the quadratic formula called the discriminant. And basically the discriminant is the number that you can calculate that is underneath the radical. Important distinction. It is not the square root of b squared minus 4ac. It is only b squared minus 4ac. Don't take the square root. If I am to ask you, or the homework is to ask you for the discriminant, it's the number, not the square root of the number. B squared minus 4ac, and you can get that. Let's, before we do a few examples, this should be a shorter lesson, I think. Before we do a few examples, let me just demonstrate. You've practiced the quadratic formula now several times. I hope that you've completed the 10.6 homework. And one of the things that controls how many, the thing that controls how many solutions a quadratic will have is this discriminant. And let's just go through the different scenarios. It basically can be three things. It can be a positive number, it can be a negative number, and if it's not one of those, the only other option is zero. Now, the vast majority of the problems that you did in section 10.6 would be a positive number. Okay, I think there was one exception where you actually got zero. So let's just get that one out of the way first, because the vast majority of the time on the problems that you did in 10.6, you got two solutions. Well, that's because this, if you follow along, whatever b is, you're plugging it in. It's a number, and it's negative b, plus some number that you get here that's being square rooted. And if it's something that's other than zero, if it's a positive number, if it's positive, then you're going to square root that number and you're going to add it to negative b. And then to get the second solution, you're going to square root that number and subtract it from negative b. That's obviously going to yield two different numbers. And when you divide by 2a, that's not going to bring them back together. So that's why you got two solutions, because over and over again, you were getting a positive number here. Okay, let's take the opposite possibility. What if it's negative? Well, if it's negative, there are things that we can do with that in courses that are higher above Algebra 1. We will deal with non-real solutions in Algebra 2 and beyond. It's a huge part of math, but it's not something we deal with in Algebra 1. In fact, if you ever are to run into this, you can just say no real solution. Okay, now that's a true statement, no real solution, because the solutions would be non-real. But again, just thinking about that. If this is negative, then you're square rooting a negative number, and right now you don't know what to do with that. One day you will, but you don't know that right now. And then the only thing that's left is zero. I believe this did happen in one problem on 10.6. It might have been number 3. And if it's zero, think about what happens. The square root of zero is zero. I'm talking about the calculation b squared minus 4ac. If it's zero, the square root of zero is zero. And then whatever negative b is, whatever it is, you're going to add it to zero, and then you're going to subtract zero from it. Well, that's just going to give you the same number both times, right? And that's probably what happened in 10.6 is you just got the same number. You got two solutions, but they ended up being the same number. You get that same number in the numerator, you divide it by whatever 2a is, you're just going to get two solutions, okay? So that's basically how it works. And let's just run through a few examples of that. And 3x squared minus 4x equals 7 is not in standard form equal to 0, so I'll make a small adjustment to that by subtracting 7 from both sides, okay? And then make a list if you want to. I try to kind of train you to make a list in 10.6, and I'll do that at least one time here. Maybe you can get away with not making a list. I do think it's pretty valuable for not making mistakes in section 10.6 to make a list. Otherwise, I myself am prone to making an error with a negative sign or something. So a is 3, b is negative 4, c is negative 7, b squared minus 4ac. Not the whole quadratic formula, but just the portion that's underneath the radical will tell us if it's even worth going forward, right? Because if it ends up being negative, then we can just stop and we could say no real solution if we were actually being asked to solve this. We're not being asked to solve it. It says how many solutions. So that's negative 4 in parentheses squared minus 4 times 3 times negative 7, which would be 16 plus 12 times 7. 16 plus 84, that's 100, right? So the discriminant is 100, meaning that, and please don't be confused when I say this, the discriminant is 100. But if we were doing the quadratic formula, you would square root 100 and get 10, and then it's negative b, so 4 plus or minus 10 all over 2 times 3. That's what you could do if you were trying to find the two solutions to this quadratic equation. For this, we got the discriminant to be 100. How many solutions does it have? 2. 2 solutions. Okay, so 100 is the discriminant. That's going to yield 2 solutions. Here, a is 1, b is negative 6, c is 9. B squared minus 4ac in this case would be negative 6 squared minus 4 times 1 times 9. 36 minus 36 would be 0. The discriminant here is 0. And if the discriminant is 0, then there's going to be one solution. This here was 2 solutions. Okay? And then finally, 5x squared plus 8 equals 2x is also not in standard form, so I'll make a quick adjustment. 5x squared minus 2x plus 8 equals 0. This would be negative 2. Coincidentally, all three of these had a negative b value. That doesn't have to be that way. But when we do plug that in and square it, it becomes positive. Minus 4ac, a is 5, and c is 8. So here you have 4 minus 160. Wouldn't this be negative 156? The discriminant itself is negative 156. Okay? Now again, imagine what would happen if you're trying to do a 10-6 problem, and you're trying to solve, and you got negative 156 under here. You didn't run into that in the homework, but if you did, the answer would be no real solution. The solution would be, or what you should state as your answer is no real solution. To answer this question accurately, how many solutions? 0 solutions. Okay, now one other thing. I put these two in the same category. This is the no solution situation. These two I put in the same category. You had the potential for 2 solutions, and just turned out to be the same number. You got 2 numbers, and they turned out to be the same number. So these are the situation where you get real solutions. This is the situation where you'll one day learn in Algebra 2 that there are 2 non-real solutions. All right, now one more thing about that, and then I have a little bit more to get to. When there are 2 solutions, you're probably tired of me talking about graphs, but I can't stop. It's because the parabola passed through the x-axis twice. Something like this, or like this. However you want to have that, you've got 2 places where it's crossing the x-axis. That's the 2 solution situation. The 1 solution situation would be where it's just comes down and touches the x-axis, a parabola that does something like this. There's just one point right here where it touches. That's supposed to be a point where it touches. In fact, you all took geometry already. Maybe you remember the word tangent. When a line was tangent to a circle, it was when it just touched it at one point. That's what this is. This is tangent to the x-axis. This parabola right here, right? If it just touches, it doesn't have 2 points, it doesn't have 0, it's just got 1. That's the 1 solution situation. Whereas the 0 solution situation is a parabola that lies entirely above or entirely below the x-axis. So that's a nice link up between the graphs and the discriminant, how you're calculating the discriminant. All right, so a quick summary then would be if you have a positive discriminant, 2 real solutions, a negative discriminant is 0 real solutions, and a discriminant that is 0 is 1 real solution. Sometimes I'll see my colleagues do something like this. If b squared minus 4ac is greater than 0, then 2 real solutions. If it's less than 0, then no real solutions. If it's equal to 0, then it's 1 real solution. Okay, so then just one little example to see how this might apply. It says a football is punted from a starting height of 3 feet with an initial upward velocity of 40 feet per second will the football ever reach a height of 30 feet? We keep coming back to this. The h equals negative 16t squared plus the initial velocity 40t plus the initial height, which is 3. That means that the ball leaves the punter's foot at a height of 3 feet. Okay, this is a reasonable model here. And the question is, will it ever reach a height of 30 feet? As in, will this ever be equal to 30? So take a look. 30 equals negative 16t squared plus 40t plus 3 is not equal to 0. If I subtracted 30 from both sides, you'd have minus 27 as your C value. Now, it is worth addressing, I guess, right here, because I don't think I've mentioned it yet. If everything were on the other side of the equation, right? Maybe I decided to add 16t squared to both sides, subtract 40t, and subtract 3. I don't know why you would do that, but maybe you had that question. Some equations would be a little bit more conducive to that. You'd get the same solution. You'd get the same answers, which is where they cross the x-axis, either 2 or 1, or I think in this case it's actually going to be 0. Anyway, I just wanted to mention that. So anyway, what we did here is we subtracted 30 from both sides. That means that A is negative 16, B is 40, C is negative 27, and we are going to calculate B squared minus 4AC being 40 squared minus 4 times negative 16 times negative 27. Now with those slightly larger numbers, I am going to use my calculator here. And it comes out to negative 128. Okay, now think about that answer. Will the football ever reach a height of 30 feet if our discriminant is negative 128? The answer is no. Basically, what we've figured out via the quadratic formula and the discriminant, which is within the quadratic formula, is that to reach a height of 30 feet, there are no real values. This means no real solution. There are no real values for t that would cause this to be equal to 30. That's what we just figured out. Now, I want to end this video here quickly, but just one other, question to pose. Could we change the height? Maybe it doesn't reach a height of 30 feet. In fact, we just showed that it doesn't. Could we change the question? What about 20 feet? What about 25 feet? If you plugged in a 20 here, it would only change one number. If you plugged in a 20, let me do it in a different color. If we plugged a 20 instead of a 30, that would go there. This would be negative 17 instead of negative 27. This would be negative 17. And in fact, I kind of tested this out real quick before I started this video. It comes out to a positive number. That means that there are real solutions. There would be 2 real times at which it passes 20 feet, once on the way up and once on the way down. So then we would change our answer. If this had said 20 instead of 30, the answer would have been yes. But as it is, because we got a negative discriminant, the answer is no. All right, thanks for tuning in.